Hi students, next continuation, that is important conversions for EAMCET and NEET. Now first example, that is unsymmetrical alkene, that is 1-propene. 1-propene react with HBr in the presence of peroxide. It is belongs to anti-Markovnikov rule. 1-propene react with HBr in the presence of peroxide. It is belongs to free radical addition. It is belongs to free radical addition. In this first step is what happens, student? Here this Br will attacks carbon which contain more number of hydrogens. Hydrogen will attacks carbon which contain less number of hydrogen according to the anti-Markovnikov rule. According to the anti-Markovnikov rule, this Br will attacks carbon which contain more number of hydrogen. Hydrogen will attacks carbon which contain less number of hydrogen. Generally addition always double bonded carbons only. Generally addition in between this carbon and this carbon only. So what is the A composition? We get that is product is CH3 CH2 then CH2Br. That is 1-bromopropane. This is A composition. 1-propene react with HBr in the presence of peroxide. It undergoes free radical addition reaction. It belongs to anti-Markovnikov rule. This reaction follow the anti-Markovnikov rule. According to the anti-Markovnikov rule, Br will attacks carbon which contain more number of hydrogen. Hydrogen will attacks carbon which contain less number of hydrogen. So this generally this Br will attacks this carbon and hydrogen will attack this carbon. We get that is CH3 CH2 CH2Br. That is 1-bromopropane. A compound is 1-bromopropane. When A compound react with what happens to next step, what to do, student? That is KCN, potassium cyanide. KCN, potassium cyanide. This potassium cyanide is strong ionic bond is present, student. In between potassium cyanide K and cyanide, strong ionic bond is present, that is K plus and Cn minus. And here also same thing, student. Here bond cleavage, this carbon getting positive charge and bromine getting negative charge. So here in this step that is conversion of A to B, that is belongs to nucleophilic substitution reaction. Why? Because this Br minus replaced by Cn minus. This Br minus is replaced by Cn minus. So we get that is final product is CH3 CH2 then CH2Cn. That is propyl cyanide, that is cyanopropane, that is cyanopropane, that is this is B compound. This is B compound. In this first step is that is addition, free radical addition to give A compound, then conversion of A to B, that is belongs to nucleophilic substitution reaction. In this conversion of A to B, this is belongs to nucleophilic substitution reaction. In this conversion of A to B, nucleophilic substitution reaction is participating. So here in this reaction nucleophile is replaced by another nucleophile. Cn minus is strong nucleophile. So here this Br minus Br minus is replaced by Cn. So we get that is B compound, and that is IUPAC butane nitrile. The IUPAC name is called butane nitrile. This is B compound. This B compound react with again what to do, student? This B compound react with again H3O plus. This B compound react with again H3O plus. Means that is hydrolysis. You remember, student, cyanide and hydrolysis, what is the production? I gave all the previous video, student. You remember, student, when RCN, alkyl cyanide and hydrolysis, we get acid CH3 COOH plus NH3. If in case when RCN, reduction with lithium aluminum hydride, it gives primary amines or CH2NH2. Remember simple trick, students. When alkyl cyanide on hydrolysis to give acid, this carbon is converted to COOH, N is converted to NH3, and same alkyl cyanide react with lithium aluminum hydride to give this carbon is converted to CH2, N is converted to NH2. This is a, you remember, student, cyanide hydrolysis to give acid group and cyanide reduction with lithium aluminum to give CH2NH2. This is the simple texture. Now what to do, student? In this step, this cyanide, this remaining part as usual same CH3 CH2 CH2. This propyl group same, does not change. After that, this cyanide on hydrolysis to give acid. What is the final production? That is CH3 CH2 then CH2 then COOH plus NH3. This is the C component. Once again student, that is remaining same, CH3 CH2 does not change, but this cyano group on hydrolysis in the acid catalyst, H3O plus acid catalyst, to give the C is converted to COOH, N is converted to NH3. Simple trick student, to give that is butanoic acid is formed. Butanoic acid is formed student. This butanoic acid again react with, this is C compound student. This C compound react with, next step now what to do student, the C compound react with sodium metal. The C compound react with sodium metal. What happens student, that is this hydrogen replaced by sodium, we get that is CH3 CH2 then CH2 then COONA, that is sodium butanoate, CH3 CH2 CH2 COONA, that is substitution, hydrogen replaced by sodium, we get that is sodium butanoate, that is D compound. So this is the D compound students. When D compound react with NaOH plus CaO, this name is called soda lime. When D compound react with NaOH plus CaO, this name is called, that is soda lime. It is also very most important student. This D compound, that is sodium butanoate, react with soda lime to give, that is decarboxyl. In this step is decarboxylation. Decarboxylation means what student, that is removal of carbon dioxide. Bond cleavage here, this complete bond cleavage, we get that is butane is formed, CH3 CH2 propane is formed, CH3 CH2 then CH3 plus Na2CO3. Propane is formed. This is bond cleavage here, here sodium, here also one sodium, here also one sodium, that is Na2. See, here also one carbon is there, 1 2 3 3 oxygens are there, Na2CO3, and this hydrogen in NaOH it contain NaO, one hydrogen, here bond cleavage. This hydrogen combines with this CH2, we get that is CH3 CH2 CH, there is propane is formed. This is the E compound student, this is the final production. This is a simple trick for conversion student. First step is free radical addition, second step is nucleophilic substitution, and third step is that is hydrolysis, fourth step is that is substitution again, and fifth step is that is decarboxylation. This is a simple trick student. Now take the one more example student. Same thing, when propyl chloride CH3 CH2Cl react with alcoholic KOH to give a compound. What is the role of alcoholic KOH student? This alcoholic KOH act as a dehydrohalogenation. Dehydrohalogenation means what student? That is removal of one hydrogen and one halogen from adjacent carbon. Removal of one hydrogen and one halogen. Halogen taking from this carbon, hydrogen taking from this carbon. We get that is product is CH3 CH double bond CH2. Simple student. This, what is the role of alcoholic KOH? The alcoholic KOH act as a dehydrohalogenating, that means elimination. Removal of one halogen from here, removal of one hydrogen from adjacent carbon, we get that is CH3 CH double bond CH2, that is one propene is formed. This is A compound student. This is A compound. When A compound react with H2 by nickel, A compound react with H2 by nickel act as a catalyst, that is called catalytic hydrogenation. That is addition reaction. We get that is two hydrogens are there, one hydrogen combines with this carbon, one more hydrogen combines this carbon, we get that is CH3 single bond CH2 then CH3. This is the B compound student. This B compound react with, this first step is elimination, second step is hydrogenation, that is free radical addition. You remember student, catalytic hydrogenation belongs to free radical addition, that is free radical mechanism. Catalytic hydrogenation, free radical mechanism participate. So this B compound, this B compound react with Cl2 in the presence of sunlight. Cl2 in the presence of sunlight, what is the role student? That is halogenation. Halogenation means what student? That is replace of one hydrogen, and hydrogen is replaced by chlorine. Halogenation, that is substitution reaction, that is belongs to propane react with B compound react with Cl2 in the presence of sunlight, it belongs to free radical substitution reaction. Substitution means one hydrogen replaced by one chlorine. Here two product will be produced student, two product will be produced student, one chlorine will attack this carbon and one chlorine will attack this carbon. So here one primary halide is formed and secondary halide is formed. So here we take the secondary halide is the major product, so we consider the secondary halide only, that is CH3. We take the this carbon only, we take the secondary halides CH3, CHCl, then CH3. This is the C compound student. When propane react with chlorine in the presence of sunlight, two types of product will be formed. One is 1-chloropropane, another one is 2-chloropropane. 2-chloropropane is the major product. We consider the only major product only, that is 2-chloropropane. 2-chloropropane is, that is a C compound. When C compound react with, next step now what to do, the C compound react with lithium aluminum hydride. Lithium aluminum hydride, it is also act as a strong reducer. Lithium aluminum hydride act as a strong reducing agent. So strong reducing agent, so that's why here chlorine replaced by, that is hydrogen, we get that is CH3 single bond CH2, then that is propane is formed. Lithium aluminum act as a strong reducer, it reduced with halide group also. Lithium aluminum hydride act as strong reducer, it can reduce primary halides and secondary halide. Remember student, primary halides and secondary halide to give alkanes. We get that is final product is, this is a D compound student. In this first step now what to do student, first step is elimination student, that is dehydrohalogenation, and second step is, that is hydrogenation, that is catalytic hydrogenation, that is addition reaction, and third step student, the conversion of B to C, that is free radical substitution reaction student, then conversion of C to D, that is reduction student, that is reduction, that is also substitution reaction. Here chlorine is replaced by hydrogen. This is the simple trick student. If you like my video, please like, share and comment. Thanks for watching students.